Alrighty, so we're going to look now at section 1.6. Last time in 1.5 we talked about solving quadratic equations. So this time we're going to talk about solving other equations. Alright? And the first one of these that we're going to solve are polynomial equations. So we've got polynomial equations. Now, polynomial equations, we can identify these because there's only one variable, like x or y or z or whatever. All the exponents are whole numbers, they're actually positive. Okay, so that's how we're going to recognize polynomial equations. So polynomial equations would look like something, 3x to the fourth equals 7x squared. That's a polynomial equation because you've got one variable, they're both x's, they're both being raised to positive whole numbers, so they're real straightforward. Polynomials. There we go, let's try that again. X to the third plus x squared equals x to the fourth plus, let me try that again. X to the third plus x squared equals 4x plus 4. That's also a polynomial because you've got the same x values throughout. They're all x's. They're all raised to positive whole numbers. And then you've got a constant term out here, and that's okay. And then another example would be something like x squared plus 5x plus 6 equals 0. And hopefully you would recognize this as a quadratic. All right. So we're going to keep a second page over here open. And on this page we're going to talk about strategies. Okay. So you get a strategies page for section 1.5. We're going to have a strategies page for this one as well. So for polynomials, we're going to solve these by factoring. Solve these by factoring. Now, remember, whenever we factor, that means we want get everything on one side. Alternatively, we mean get everything set it equal to 0. Okay, so that's what we mean. Get everything to one side when we're solving by factoring. Once you get everything to one side, there's a couple of different strategies. We can, what is the word I want to say? We can factor out like terms. We can do the reverse foiling. So like unfoiling, so you've got blah 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 squared plus blah 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 x plus blah blah blah. And we go so that kind of thing, reverse foiling. And then the last method that you can use there would be grouping, factoring by grouping, and we'll do a quick example of that as well. So let's look at a couple of practice problems. Well, actually, let's just work these. That'd be fun. Let's work these problems. So let's work this first one. We've got 3x to the fourth equals 27x squared. And in order to solve this, we want to get everything onto one side. Because if we're going to factor it, that's the way to do it. We got to get everything to one side. So let's subtract 27x squared from both sides. So we've got 3x to the fourth. 3x to the fourth minus 27x squared equals 0. And we look at our strategies. And our strategies factor out like terms. It's the first one. We'll see if that'll work. Factoring out like terms. That'll work. Alrighty. So what can we factor out of each one of these terms that'll work? They both have a 3 in them. And they actually both have an x squared in them. So I can factor out a 3x squared. If I factor 3x squared out of this first term, I'll get an x squared. And if I factor 3x squared out of the second term, I have a minus 9 left. Now, the thing with factoring is you have to keep factoring until you're all done. Remember now that this is the difference of squares. It's going to be x plus 3, x minus 3. And now that we've factored, we can set everything to 0. So we can say, okay, well, 3x squared is 0, x plus 3 is 0, and x minus 3 is 0. So we can divide here both sides by 3 to get x is 0, or x squared is 0, and then from there directly determine that x is 0. This one we can subtract 3 from both sides to get x equals negative 3. And here we can add 3 to both sides to get x equal to 3. So that means x is negative 3, 0, or 3. And any of those should work. So that's good. Alrighty, let's try this next one. X cubed plus x squared, that. So we've got x cubed plus x squared is equal to 4x plus 4. And we want to factor, so that means we have to move everything to one side. Don't worry about the next step, just worry about moving everything to one side because that's the most important thing. You can't factor until you move everything over to one side. Alright, so I've got x cubed plus x squared minus 4x equals 4. Subtract 4 from both sides. I've got a wobbly table. And I've got x cubed plus x squared minus 4x minus 4 equals 0. Now, I've got 4 terms, and I have to factor this somehow. We go back and look at our strategies. Grouping. Well, we can't reverse FOIL it because we've got 4 terms, and we can only do this for 3 terms. So make a little note here. This is usually best with 4 terms. That's usually when you're going to do this. The other thing you really want to remember about grouping is you don't want to group terms around a negative sign. So don't group around a minus sign. Okay. So we've got this, and the idea is we want to be able to go, oh, look, chicka chicka choo, and blah, 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 blah. But we can't do that right now because we just said we can't group around unless we can't group around a negative sign. So what we need to do is we actually need to rewrite this. And instead of having a minus 4 here, what we really want to put is plus a negative 4x minus 4. Now this is algebraically equivalent, it just looks a little funny. Plus a negative will give us minus 4x. All right. So now that we have that, what we'd like to do is go ahead and group. Go ahead and group like this. We can do this now because we're grouping around a positive. So what I want to do is say, okay, well, what can I factor out of these first 2 terms? I can factor an x squared. And if I do that, what's left? Well, the first term would be an x, and now the second term would be a 1. Now what about the second one? What comes out of here? What can I factor out of here? Factor out a negative 4. And if I factor a negative 4 out of each of those terms, who's left in the front? Right here will be an x, and over here be a positive 1. Okay? So now here's how the theory goes with grouping. If we have 6, or however many, if we have x squared puppies, so we have x squared puppies plus negative 4 puppies, then that means we have x squared minus 4 puppies. Okay? So that's how you want to do this. Now, if you foiled this out, if you foiled this, you would get that. These are equivalent. So you can even test it if you don't believe me. X squared minus 4 times x plus 1. First, x cubed. Outer plus x squared. Inner minus 4x. Last, minus 4. Check it out. They're exactly the same. Right here as right here. So we did that absolutely correctly. And that's just how factoring by grouping works. It's just that awesome. All right. Now we're not quite done because we always like to factor as long as we can. So we have this x squared minus 4, difference of squares. So we can factor that out to, so we're just going to factor this x squared minus 4 out to x plus 2 and x minus 2. Okay? So now what we can do, we can have 3 terms that all multiply together to get 0. So that means one of them better be equal to 0. Alrighty. Subtract 2 on both sides to get x equals -2. Add 2 to both sides to get x equals +2. And subtract 1 from both sides to get x equals -1. So my options are -2, -1, and 2. Now order doesn't matter, I'm just writing them in order because I'm particular, but that's all there is to it. Alright, then we had one more example of a polynomial equation, and it was this one down here. X squared plus 5x plus 6. X squared plus 5x plus 6 equals 0. Okay. So we've got this one. Now we can't factor by grouping because we've only got 3 terms. We can't factor out a common term because they don't have one. So let's go back to our strategies and look, and we go, okay, so this is what I want to use. I want to use my reverse foiling. Good, because I like doing that. Because I'm cool, that's why. So I'm going to reverse FOIL it. We talked about this kind of at length in the previous section. This is a positive, and this is a positive. So since this is a positive, it means the signs are the same. And since this is a positive, it means they're both plus. Since the coefficient in front of this term here is 1, that means each of these are x. And then our 6, that'll pull us out to a 6. No, that's not going to work. How about a 2 and a 3? So let's check it out and make sure it works. All right, we got first, outer, inner, last. Perfect. All right, that's what I wanted it to be. All right, so I've got 2 things equal to 0, so either the first one is 0 or the second one is 0. Subtract 2 from both sides to get x equals -2, or add 3 to both sides. Ooh, not add 3. I was all excited. Or subtract 3 from both sides to get x equals -3. And so you have your solutions, -2 and -3.